Okay, I'm going to try this again. All right, we are going to look at hypothesis testing in chapter 17. This is important because what if a company, drug company, let's say, claims that their cholesterol medicine will decrease your cholesterol by 5 points? Is that a valid statistical claim, or is that something that is not true? So we're making inferences from our data. So there are two things that we really have to make sure we understand. Part of the process at the very beginning is identifying the hypotheses. And this is sometimes difficult to do. We label them with an H naught, H sub 0. That's identified as the null hypothesis. And then we have H sub A, which is known as your alternative hypothesis. In the null hypothesis, you should have an equal sign of some sort, whether it's less than or equal to, or greater than or equal to. And then in your alternative hypothesis, you should not have an equal sign at all. So here are your possibilities down below. You could have possibility number 1, your null hypothesis could be an equals, and that would make your alternative not equals. Number 2, your mean could be less than or equal to for your null, then it would have to be greater than for your alternative. And the last option, number 3, your mean could be greater than or equal to for your null, and it would have to be less than for your alternative. The significance of this would be if you have a normal distribution, let's say in this picture right here, you would, your first less than or equal to would cover this end of things, and your alternative would be the right-hand side. So it covers all of your normal distribution, basically. So here's a list of steps from what we want to do to go through this hypothesis testing process. So the first thing we're going to talk about is your null and alternative hypothesis. You need to identify these. These are not from your sample, not from your sample. This data is going to be a claim that they typically make. Again, your null has to have something with an equals in it, and your alternative has not, does not have an equal sign. You need to identify your level of significance. Typically, this is shown with an alpha symbol from the Greek alphabet. Typically for us, it's either going to be 0.1, 0.01, or 0.05. That means we are 99% confident, 90% confident, or 95% confident. Then we need to identify our X bar and N. This is from our sample. And then we need our standard deviation for the population. We then go and use the applet. The applet does the calculation for Z for us. We've already done that one many times. It also gets our probability for us using the Z-score table, which is this p-value that we're going to need later on. We're going to take that p-value and compare it with the alpha from up here in step number 2. If p is less than alpha, then we are going to reject the null hypothesis. If it is not, we are not going to reject our null hypothesis. Then we're going to write some sort of sentence in the context of the problem with our final decision. Okay, so here's my first example. The only problem with this is that it did not, the math font and some of the numbers didn't come through, so I'm going to have to write them out for you. So it says, in order to monitor the Florida Everglades, various measurements are recorded. We really don't need that information to solve this. It did say that it got 61 temperatures on 61 different days. And it did say that the mean for those 60 temperatures was 30.4. Those 61 temperatures, sorry. It says that the standard deviation for the population was 1.7 degrees Celsius. And we want to test to see if the mean is greater than 30. Test the claim that the mean is greater than 30. So what we need to do, according to the steps from the last page, is we need to first identify our null and alternative hypotheses. Because we need an equal sign for our null and we want the mean greater than 30, that means we're testing if it's greater than 30, so that's going to be on the alternative hypothesis. Again, there's no equal sign in there, so it can't be the null. That means that the null has to be less than or equal to 30. Again, there's our equal that we need in there. Step number 2 said make sure you know your significance level, and we do that. Alpha is 0.05. Step number 3 on the previous slide said to identify your X bar. X bar is from our sample. That is the mean of 30.4 right here. It said to make sure you know how many values were looked at, and it was 61 were sampled. And it said to make sure we know our population standard deviation. So now we need to use the applet. I'm going to go there right now. So in this case, we're going to type in our null hypothesis. You can only type in the number here. You can't change it from equals. It will know what's going on in the next step. And then right here in the alternative hypothesis, our mean was greater than 30, so that's what we want to do. Notice how all the other numbers change to the 30 once we type in that null hypothesis. My population standard deviation was 1.7. My N value, there were 61 temperatures recorded. And we will always select this one here. I have data and the observed X bar is. We will always select that. That's always going to be given to us. And in this case, our observed X bar was 30.4. And then we hit update, and it gives us a picture. And in your picture, your alternative hypothesis is typically shaded, the greater than 30 right here. And this p-value is what we want, which is 0.0331. And that's your probability that that's going to happen. So we're going to go and write that down. So that's the next thing that we needed. P equals 0.0331. And so now we have to see, is P less than alpha? Is 0.0331 less than our significance level of 0.05? Yes, it is. So we should reject H naught. So I'm going to take and put a big ol' X through our H naught. That basically means, in the context of the problem, that there is sufficient evidence at the 0.05 significance level that the mean bottom temperature in the Everglades is greater than 30 degrees Celsius.